5. I'm sorry for those of you that are very linear. This lesson has been very destructive because we went example 2, then example 3, then example 1. Now we're doing example 5. The pi over 12 questions, or the 15-degree angle questions. Without our calculators, we need to find the exact value of cos of pi over 12. So the strategy that we're going to use is the following. We are going to use the families we already know, our pi over 3, pi over 6, and pi over 4 families. And add or subtract them to get the pi over 12 family that we're looking for. I love pi over 12. Students also love pi over 12 questions because they are, just like the double triangle question, very predictable. I found a lot of the questions you had to do for your Chapter 6 test were somewhat unpredictable, which made them harder. With Chapter 7 major questions, they're very predictable, which means if you study them and learn them, you will get good marks on them on your quizzes and tests. So that's usually a positive thing. The proofs, they're still a little bit unpredictable, right? Those ones you just have to practice lots of them to get good at them. Everybody good? So, if we take pi over 3, pi over 4, and pi over 6 and made them over 12. So do you see how I took the pi over 3? I said that, if I made it a denominator of 12, would be the same as 4 pi over 12. And pi over 4 is 3 pi over 12. And pi over 6 is 2 pi over 12. Can you see two different ways that you could subtract to get pi over 12? I could take two of those and subtract and get pi over 12. You see that you could take pi over 3 minus pi over 4, or pi over 12 minus 3 pi over 12 would be 1 pi over 12. Or you could take pi over 4 and pi over 6 and subtract. So what we have when we're figuring out a cos of pi over 12 is we could say, well, cos of pi over 12 is just 4 pi over 12 minus 3 pi over 12. But by writing it this way, we have our alpha minus beta formula. So is everybody okay with what we did here? We figured out two things that subtracted to get pi over 12. 4 pi over 12 minus 3 pi over 12. The 4 pi over 12, that reduces to pi over 3. The 3 pi over 12 reduces to pi over 4. So pi over 3 minus pi over 4. And this is our alpha minus beta formula. So we go to our formula sheet and say, what is cos alpha minus beta? It's cos alpha cos beta plus sine alpha sine beta. And initially, this seems like not a good idea because you make things bigger. But all of those are on your pi plate. You know all those values. And the nice thing about this unit is on this unit test, when I finally get them finished judged, and I add the bonus mark to the test, previous test to those that get it, I'm getting there, you get your pie plate on Chapter 7 test. So when you get this question, you're like, oh, I don't remember what cos of pi over 4 is. Root 2 over 2. You can look and see what it is. So what is cos of pi over 3? You should first, though, try to do it from memory. Do you remember cos of pi over 3? 1 over 2. Cos of pi over 4? Root 2 over 2. Sine of pi over 3? No. Root 3 over 2. So now our next step is we can evaluate each of those. And the last thing we need to do is get a common denominator and simplify this. Can you see that the common denominator would be 4? And you get root 2 plus root 6 all over 4. And that is the exact value of cos of pi over 12. So if you wanted to fill in that line on the unit circle, you would now know that the x-coordinate at 15 degrees is root 2 plus root 6 all over 4, which isn't a very nice looking x-coordinate, but it's there anyways. Okay. We can get pi over 12 questions in degrees. That's the next question. 75 degrees. Could you figure out two things that add or subtract to 75? 30 plus 45. That's probably the easiest. There's other ones that work. Can you see that you could take, for example, 120 minus 45? That would work. You have to take two values that are on your pi plate that add or subtract to make the pi over 12 that you want, whether it's in degrees or radians. And by the way, 75 degrees, if you change it to radians, would be 5 pi over 12. So now, there's your alpha. There's your beta. Which one are we looking for? The sine alpha plus beta formula. So you go to your formula sheet. Sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. And we write that out as our next step. And each of those are on your pi plate. I can go up just a little. I know I'm getting excited about. I go. Yeah. I'll wait for you. Because on these good questions, I just want to keep going.
Actually going to get to use a pi plate.
Yeah, the next one. Good thing. So like if you forgot sine of 45, it's now root 2 over 2. Did you forget cos of 30 degrees? That was root 3 over 2. Why do we say root instead of radical?
Yeah.
It's just the English word. We call the whole thing a radical, but we call just that sign the root. Square root, cube root, fourth root. Like
What?
okay, so go to our pi plate. Go to our pi plate. Plug everything in and simplify. And we got root 6 plus root 2 over 4. which, by coincidence, is exactly the same as the first one. Which is kind of cool. And I will tell you that for sine and for cosine, not for tangent, but for sine and for cosine, you will always get a root 2. You will always get a root 6. And you will always get it over 4. But sometimes the root 2 will be minus. Sometimes the root 6 will be minus. Sometimes both will be negative. And sometimes both will be positive. That's what's going to change. But if you don't get a root 6, a root 2, and a 4 in the end, then something went wrong if it's a sine or cosine. The tan ones just have a bunch of root 3s. Bunch of 3s and root 3s. But we'll get to tan ones eventually.
So the tangent and cotangent will suffer more 1?
No, you still have to figure out tangent and cotangent using these formulas. The tangent one, you have to use the tangent formulas. Okay? Everybody up to here? Caught up? Miriam, caught up? Excellent. Okay. The next one we're going to do is 17 pi over 12. But before we do that, I'm going to hand out their scrap paper to everybody. Take a scrap paper, pass it on, take a scrap paper, pass it on, take one, pass it on, take a scrap paper, pass it on. There we go. And I probably handed out extras, it's okay. If you have extras at the end, you can put it back into the scrap paper bin at the end. Okay? And yes, there's a joke on the back, but the ones I put in there, I didn't think were, I kept the funniest ones. But I thought these ones were not as. Okay, your job is to think of your unit circle. Okay? And you can use pi over 3, pi over 4, pi over 6, or any pi over 3, any pi over 4, any pi over 6. So you could use, maybe it works that this is 7 pi over 6 plus pi over 3. But you have to figure out two things that add or subtract to make 17 pi over 12. Once you find one, you call me over, and if I verify it, I write it up on the board, and then nobody else is able to use that one. Everybody has to come up with a different one. The longer you take, the harder it gets.
I don't even.
Two things that add or subtract, they have to be on your pi plate that get 17 pi over 12.
And either over 3 or over 4?
Or over 6.
Or over 6. Oh, yeah, I got it. This one.
Once you find one, I'll verify it. If it's verified, I'll write it up there. Then it now becomes one that's not allowed to be used by somebody else. I will pause the video so we don't have this long lull. You got one? Yes? He thinks. Let's check. This would be 2 pi over 3 plus 3 pi over 4. Okay, we're going again. This one? This green one? Yeah, you're right. It works. 2 pi over 3 plus 3 pi over 4. Now we're going to analyze this a little bit. Besides the fact that all of these work, and they all equal 17 pi over 12, they also all have something else in common. And when we see the thing that's in common in all, we came up with 6, in all 6 of them, it can help us find another one. They all have the pi over 4. Excellent. This one has a pi over 4. This one has a. Nice.
No, I just saw
Whoa! Oh! Here, wait a minute. They all have circle, yes. So, can you tell me a pi over 4 that's not up there, either positive or negative?
Looks like
Because we've got plus pi over 4, we've got minus pi over 4. We've got
minus 3 pi over 4.
minus 3 pi over 4. Perfect. Let's figure out the one that would have the minus 3 pi over 4. Now, minus 3 pi over 4 happens to be minus 15 pi over 12, right? Because if you multiply it, no, oops. Happens to be minus 9 pi over 12, right? What would have to have been first to get 17? Something minus 9 has to be 17. It would have to be what over 12? 26. What does 26 pi over 12 reduce to?
13 over 6 pi over 8.
That would have been another one. Oh. Now, you don't have to find them all, but once we realize that it has to have a pi over 4, most people start with that. And you can start with any pi over 4. So we did pi over 4, 3 pi over 4, 5 pi over 7 pi over 4. Someone could have picked 9 pi over 4. Right? Now 9 pi over 4 times by 3 would be 27 pi over 12. What would you have to subtract to get 17? You'd have to subtract 10. And 10 pi over 12 reduces to 5 pi over 6. And we get another one that works. So if you start with any pi over 4 family, you will always get the other one, which makes these a lot easier. Some people just start with pi over 4. They're like, I'm going to start with 3 pi over 12. I'd have to add 14 pi over 12 to get it. That reduces to 7 pi over 6. Perfect. Other people go, I want to start with one that's close to 17. So if I start with 5 pi over 4, which is 15 pi over 12, that's really close. I would just have to then add 2 pi over 12. That reduces to pi over 6. And it will always work if you start with pi over 4. But if you have no pi over 4, it won't work. And the reason for this was, we explained it earlier, pi over 4 is the only one when you go over 12 is odd. You get 3 pi over 12. And your pi over 12 family questions will always have an odd number, because if it's not an odd number, it'll reduce to be a pi over 6 family. Like if I had 18 pi over 12, I could reduce that, and it's no longer part of my pi over 12 family. So your pi over 12 family always has an odd number, and then you have to use a pi over 4 to do that. So when you're finding the exact value of this, start with your pi over 4 family, and think of them. There they are. They're all there. 3 pi over 4, 9 pi over 12, 15 pi over 12, 21 pi over 12. Choose one. Then ask yourself, do you like adding or subtracting? Because if you choose one that's too big, you're going to have to subtract. If you choose one that's small, you're going to have to add. Hi. Most people choose adding, so I subtract. So what would happen here is I would have done this. I chose one that was too big, 21 pi over 12. I know I have to subtract. Well, 21 minus what is 17? You'd be like, oh, I have to minus 4. And when you reduce those, they're both on your pi plate. Every single time. So this is why lots of students love the pi over 12 questions, because they're the same thing you do every single time. And because it's the same, there's no tricks to them. You always have a pi over 4 family. It's not hard to figure out what you need to add or subtract to get it to work. And they're predictable. And so you know there's going to be a pi over 12 question on your test. Therefore, it's predictable. Therefore, most people they're nice because they're like out of 3 marks or 4 marks. So it's like, woohoo, guaranteed 3 marks, guaranteed 4 marks on my test. That feels good when you can predict stuff. And then you can worry about the proofs that are a little bit more unpredictable. So then this is my alpha, this is my beta. I look on my formula sheet for my cos alpha minus beta formula, and it says cos plus sine sine. Cos alpha cos beta plus sine alpha sine beta. And you have your pi plate, so you should be able to write each of those values correct. Right? But now some of them aren't in quadrant 1 anymore. So some of them are going to be positive and some of them are going to be negative. Right? Cos 7 pi over 4 is in quadrant 4. So it'll be positive, root 2 over 2. But sine of 7 pi over 4 is going to be negative. You get negative root 2 over 2. And when we multiply that out, we'll get a common denominator of 4. Put the tops together. This time we got a root 2 and then minus root 6 all over 4. Sometimes on a test, you get this question, cos of 17 pi over 12 is part A, and then in part B, here we go. Don't want to show the answer quite yet. So what would secant of 17 pi over 12 be? And this would be a 1-mark question. Part A would be 3 marks. You just figured out cos of 17 pi over 12. And you got the answer here, root 2 minus root 6 all over 4. Perfect. Just flip it. Because they're reciprocals of each other. So the answer would get flipped.
The nice thing is just you want the C, the name CSD,
Mm-hmm.
and then part 2, and then we should just find the sign again.
No, that wouldn't be as nice. Now he's saying you do cos in part A and then ask cosecant in part B, which is a totally hard question because then you'd have to do sine for the whole thing. Yeah. Here we go. Okay, one more example. You can keep going. If you run out of room, you can go back to page 650 of space for this. This is copy and pasted from a provincial exam. So they had this question on the provincial exam. Can you see that it's a pi over 12 question? What's different about it? It has a 4 in front. That 4 in front caused some students that year completely shut down, leave this whole question blank. What does that mean? Okay? Multiply your final answer by 4. So if you could first find cos of 11 pi over 12, right, which will equal cos of, which pi over 4 should we start with? Pick one. Pi over 4? 3 pi over 4? If you pick 3 pi over 4, can you see that that would be 9 pi over 12? What would you have to add to get 11? 2. When we reduce these, we can go Well, I already knew this was 3 pi over 4 because that's what I chose, and sure enough, the other one reduces to something on your pi plate. There's our alpha, there's our beta. What's the cos alpha plus beta formula? Cos alpha, cos beta, minus sine alpha, sine beta. Equals, they're all on our pi plate. This one will be negative root 2 over 2, positive 1. Oh. Z, positive root 3 over 2. This one will be positive root 2 over 2 and positive 1/2. So we get all over 4, negative root 6, minus root 2. Okay, this is one where they're both negative. So then what would 4 cos of 11 pi over 12 be? If this is what cos of 11 pi over 12 is, and you multiplied it by 4, and you can circle question number 7.